So if we look at the problem with the bullet and the rifle, before we know that there's no movement, so there's total momentum of 0, and after the rifle recoils to the left, let's say, and the bullet moves to the right. So this is a case where we have conservation of momentum. And let's use the x direction in this case, since we have only movement in the x direction. So we can say the momentum initially has to equal the momentum finally. Initially we know we have 0, neither the rifle nor the bullet are moving. And then final momentum is mass of bullet times the velocity of the bullet in the x direction plus mass of rifle times velocity of rifle in the x direction. So we can say that the velocity of the rifle in the x direction is equal to minus the mass of the bullet, velocity of the bullet in the x direction divided by the mass of the rifle, and this gives us minus the bullet is 5 grams, so 0.005 kilograms, divided by or multiplied by the speed of the bullet, which is 300 meters per second, and it's going to the right, so it's positive, divided by the mass of the rifle, which is 3 kilograms, and that gives us a recoil velocity of about negative 0.5 meters per second. The negative sign means the recoil is in the opposite direction of the motion of the bullet. And now we can say that the momentum of the bullet in the x direction is going to equal the mass of the bullet times the velocity of the bullet, which gives us 1.5 kilogram meters per second. The kinetic energy of the bullet is 1/2 the mass times the velocity squared, which gives us 225 joules. The momentum of the rifle in the x direction would be the mass of the rifle times the speed of the rifle, and then the kinetic energy of the rifle would be 1/2 its mass times its velocity squared, and that gives us about 0.375 joules.